In this video, I'm going to go over a copy of the midterm preparation quiz to help you get prepared for the midterm exam. The first question on the proctored midterm will be the question that you see here, and it will also include formulas that you see on the screen. So let's go ahead and work on the questions. So question number 2, the set containing all the elements that are common to both set A and set B is called the blank of set A and B. So elements that are common to both A and B is called the intersection. Determine if the set is well-defined or not well-defined, the set of astronauts who walked on the moon. So if I gave that description to anybody, to several people, they would all give me the same list. So this is a well-defined set. Determine whether the set is finite or infinite. The set of odd numbers greater than 7. This is going to be infinite because it continues to go on and on and on. The numbers are greater than 7. Express the set in roster form. The set of natural numbers, so we need whole numbers, between 19 and 187. So we're going to start at 20 and we're going to go up to 186. So if we look in our choices down here, the correct answer for this is going to be D. Express the set in set builder notation. So we see the set contains natural numbers between 9 and 16 inclusive. So let's take a look at what we've got down here for the choices. So it looks like the first choice is correct. Let's just check on the other ones. Yes, and they wouldn't include both endpoints. So the correct answer here is going to be A. Write a description of the set. So the set V is the set of what? It's letters in the alphabet from G to L. Not to L inclusive, G to K inclusive, so it's going to be choice C. Determine whether the sets are equal, equivalent, both, or neither. So the set on the left has 2 elements and the set on the right also has 2 elements, so we know they're at least equivalent, but they don't have the same elements, so therefore these sets are simply equivalent, they're not equal. Decide if the given statement is true or false. So on the left side we see a single element 6, and then we look at the set on the right, the mathematical expression on the right, and it's a set with the elements 1, 5, and 6. So this is a false statement, and it's a false statement because why? 6 is an element of that set on the right-hand side, so the correct answer here is A. Determine the number of subsets of the set that contains the elements 1, 2, 3, up to 9. So we know the formula for the number of subsets is 2 to the n, where n is the number of elements in the set, so this is 2 to the 9th. And 2 to the 9th, if I do that real quickly on a calculator, let's pull up the calculator on the computer. Oops, wrong one. Pulled up the wrong package there. Let's just get that out of the way. Let's get the calculator up. So we want to go 2, and we want to raise it to the 9th power, and we have 512. So the correct answer here is going to be 512. Draw a Venn diagram that illustrates the situation described. Set A and set B are disjoint, which means they have nothing in common. So in the Venn diagram, the 2 sets do not overlap, and that's choice D. U is a set, the universal set is a set of cities in a country. A is a set of cities that have a science museum. B is a set of cities that have a zoo. We want to describe B complement in words. So B is a set of cities with a zoo. So B complement is going to be what? The set of cities that do not have a zoo. And that's going to be choice C. Okay, so now we have a Venn diagram, and we want us to pick where a particular country would fall. And we have 3 categories, whether they produce corn, rice, or wheat. So let's look and see where country X falls. Do we see it in the first grouping? No, I don't see it in the second grouping, and I don't see it in the third grouping. So if it's not in any of the 3 sets, it must go into region number 8. So the correct answer there would be region number 8. Question 14 says, use the Venn diagram to list the elements in the set A union B, take the complement of that in roster form. Now for some of these problems, I have what I call detailed solutions because it was a little too hard to just write it on the screen for you and wanted to explain how I did the problem. So from the Venn diagram, we see that the universal set is all the elements under consideration, and that's the set of the elements 1 through 14. And actually that's set B, our answer B rather up there. So let's find A union B. And if you look on the diagram here, if I change my colors, all right, I don't see my drawing tool right now, but I can do it with the drawing tool I have here. So A, no, I'm not drawing. Let's go back over here. I was drawing over here. I don't know why I can't draw over here. Let's take a look and see. Oh, here. Let's do red. So if I go in my diagram here and I take all the elements first that are in A union B, I'm really just circling here, and I see that it's all those elements there. And if you put them all in a list, you come up with, right down here, 3, 4, 6, 7, 9, 11, 12, and 13. And then you want to take the complement of that, and that's everything that's in the universal set that's not included in A union B. And I can do that by looking at the universal set and then crossing out the elements that I haven't put into A union B. I can also do it on the picture. If I change my color back here, if you notice, everything outside of A union B is going to be elements right here. So it becomes 1, 2, 5, 1, 2, 5, 8, and 10, which I have written right down here. So the correct answer in this case is choice A. And I think I have a detailed solution for the next one. Yeah, I do. This is a Venn diagram problem. The Greens are moving and the real estate agent located 81 houses for sale in their price range. Of the houses for sale, and there's a list of information given here, and then we want to answer some questions. So let's take a look at how we work this. So we know that there's two sets. Set A is going to be the house has a basement, and set B is going to have a garage. And here's the general form of my two-set Venn diagram. So we're going to start with region 2. How many houses had both? And that's 33. So that number is going to go right here into region 2. Now we know set A is basement, and we know there's a total of 46 with a basement, but we've already accounted for 33 of them because they also have a garage. So we're going to do subtraction, and we're going to find out that 13 is going to go right here in region 1. They have only a basement. And by the same rationale, same reasoning, I've got 48 houses that have a 3-car garage, but 33 of those also have a basement. So therefore, I'm going to subtract the 33, and I'm going to come up with 15 houses that only have a garage. So here's my Venn diagram so far. And then I need to know how many don't have either one. And if you remember back up here, it told us there were 81 houses total. If I add these three numbers together, I get 71. So I have a 10 back here for region number 4. So here's my completed Venn diagram. So how many houses had a finished basement, not a 3-car garage? And remember, set A is basement and B is garage. So had a finished basement, not a 3-car garage. So this is going to be 13 right here, 13. How many had a 3-car garage but not a finished basement? That's going to be 15. And then finally, how many had either? And remember, we just added those up, the 13 plus the 33 plus the 15, and that is 71. And I think I've got one more over here on the detailed solutions, another Venn diagram problem. Mrs. Bolo's second grade class of 30 students conducted a pet ownership survey, and the results show that 8 have a cat, 15 have a dog, and 5 have both. How many students had no dogs? So again, two sets. I'm going to let set A be cats and set B be dogs. I'm going to create the same two-set Venn diagram. So let's see, there are 8 students. Set A is with a cat, and there are 8 students in this set. To find the region, remember there are 5 that had both, so that's going to go in region 2. 8 had a cat, so 8 minus 5 is going to give me a 3 for region 1. Let's see, 15 had a dog, but I already put 5 into region 2, so that's going to give me 10 into region, there should be region 2 here. Let me cross that out, that should be region 2. And then when I put those in, I've got 3, 5, and 10, that's 15, I'm sorry, 3 and 5 is 8, 18, and there were 30 students in the class, so 12 students don't have a cat or a dog. So now we can answer the question, how many students have no dogs? All right, so remember, we said that set A, or set B rather, is dog. So no dog is going to be 3 plus 12, or 15 students. So the correct answer here is going to be 15. All right, and I think I have detailed solutions for the next couple. No, I don't. Okay, let's go back over here. All right, make sure we got our pen going again. Okay, so we did that one, and we did this one. Okay, so we're up to number 17. The process of reasoning to a general conclusion through the observation of specific cases is called what kind of reasoning? And that's inductive reasoning. Use inductive to predict the next 3 numbers in the sequence. So what's the pattern that we see? 12 minus 12, 12 minus 12. So the next 3 numbers are going to be 12, minus 12, and 12. That was a pretty easy one. Now this one I did give you a detailed solution for because it's a little bit more complicated. So what's the pattern? We have 1 triangle here, 4 triangles here, 9 triangles here. So how did we get from figure 1 to figure 2? We added how many triangles? 3. How do we get from figure 2 to figure 3? We added 5 triangles. So we added 3 here, and we added 5 here. So reasonably, what would we add here? 7. So that would take us up to 16. The other way to look at this is 1 squared. This is 2 squared. This is 3 squared. So there's another way to look at the pattern, and this is 4 squared. So 2 ways to look at that pattern. Sometimes it's helpful to see more than one pattern in a problem. Write a negation of the statement. She earns more than me. So remember, when we write a negation, we want to look at the truth value of the original statement. And let's say that this statement is true. Let's just say that was a true statement. So when we negate it, it has to be false. So what's going to be the negation of this? She does not earn more than me. And that's going to have a false truth value. Okay, and we want to translate into words. So we have the symbolic form here. They gave us the simple statements, and it's got a negation in front, which means it is not true that, so I can eliminate the first 2. They don't belong with, or begin with, it is not true that. And we start with the I eat bananas, or this is an octopus. So the correct answer is the third choice. And now they want me to write this in a symbolic form. I get an A, which is P, and the play is boring, Q. Okay, number 23, I have a detailed solution for this one because it takes a bit more work on this one. So for number 23, we want to translate this into symbolic form. The doctor did not prescribe medicine, so not P, but is and the patient recovered. So there it is symbolically. And you can see in all 4 choices, that's the correct representation of the sentence. Now we have to build the truth table. So down here, I put in my truth values, my P's and my Q's. Column number 1 is the negation of P, true, true, or false, false, true, true. And then column 2 is the Q truth values. And then the connective I'm using is and. So I have to have at least 2 truths, both true simple statements. And the only time I get that is in case number 3. And this correct answer is B. And number 24 I have over here also. In this case, we're doing like 1 row of a truth table. So I've given you a symbolic statement, and then I've given you the truth values for the simple statements. So it told me that P is false, and I've got a not P in this. So then I know if P is false, not P is true. And we're going to replace the simple statements with their truth values. So not P is true. They told me Q was true. P is false. And R is true. So I've just put these and replaced them in place of the simple statement symbols. And over here, I've got true and true, which gives me true. In my parentheses here, I have false and true, which gives me false. Now I'm going to negate that false to get a true and a true gives me a true. And then the second situation, they've changed the truth values now. Now P is false, so therefore not P is going to be true. And we don't need to check on the other one. So we're going to replace not P with a true, Q with a false, P with a false, and R with a false. So on the left side, I've got true and false, so I get false. On the right side, I've got false and false, which gives me a false. Negate the false to get a true. False or true gives me true, so the compound statement is true. Another detailed solution here, construct a truth table for this statement here. So right down here, I've got my truth table. I've got first column is going to be the not T here. And then second column is Q. Connective here is and. So I'm looking for 2 truths, which only happens in case 3. Then I brought my negation of T's over here, and I have a conditional now. The time that a conditional is going to be false is when I have a true to a false, which I see in the 4th case. So I've got true, 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 false, and let's see, it's C. C is the correct answer for that one. And then 26, similar to what we did before, but this time we're working with a conditional statement. And again, you can follow my work here. I'm going to let you look through that, but you come out with a false on that one. Now this one says, use DeMorgan's laws or a truth table to determine whether the 2 statements are equivalent. And we've got P or Q, and then we've got negation, parentheses, negation P or negation Q. So I'm going to work with this part here, because it looks like this part, De Morgan's law. And instead of having P, I have not P, and instead of having Q, I have not Q. So that's where I'm going to start. And look at the pattern. The P went to not P, so my not P goes to, I've got it, actually the negation here. It's going to go to a negation, it's going to go to P. And then the not Q, remember the Q goes to not Q, so a not Q is going to go to a Q. And therefore, and also the AND statement goes to an OR statement. So here's what I end up with, and these two statements are equivalent. All right, so then let's go back over. And so now we're up to 28. All right, and write the contrapositive of the statement. So remember, contrapositive, they're flipped and negated. If the triangle is not an equilateral, then the three sides of the triangle are not equal. So this is going to become the first, the antecedent, but not negated. So if the sides of the triangle are equal, then the triangle is equilateral, and this is a true statement. So the correct answer here is B. All right, and now we're moving into the geometry. So fill in the blank. Two lines in the same plane that do not intersect are, parallel lines. Okay, and I want you to identify the figure and notice the blue part of the figure here. So this is what's called an open line segment, and the answer is given, no, I'm sorry, given right here. It's not correct. It's this one here, sorry. Open line segment KG. Classify the angle as acute, right, straight, obtuse, or none of these. And you notice that little box in the corner there, and that tells us this is a right angle. Find the requested angle, and we want to complement. So I've got a detailed solution for this one. And remember, complementary angles add, their measures add to 90 degrees. So I took 90 and minus 36, and I got 54, which is answer B. What one was that? Okay, this is another one I have a detailed solution for. So we've got a little picture here. We've got two angles that are complementary, so that means their measures add up to 90. So I know that x plus 11x plus 42 must equal 90. Combine terms on the left side, so I get 12x plus 42 is 90. Subtract 42 from both sides. And this should be a 42, I'm sorry, it should be just 48. 12x equals 48, and then divide by 4x, and you get divide by 12 rather, and you get x equals 4. So the measure of angle 2, this is 4 degrees. And then two ways to find the measure of angle 1. You can go back to the expression for it, which I did here, and I come up with 86. I also know they're complementary, so I could simply subtract 4 from 90 to get the measure of angle 1. And then we've got one here with a transversal. And they've given me the measurement of angle 8 here as 53, and they want me to find the measure of all the other angles. So there's a lot of good relationships in here. So that we know angles, this should say 1 and 8 right here are supplementary, so we can find the measure of angle 1 by subtracting 53 from 180, so this one's 127. And then you can continue working through this. These are vertical angles, 1 and 7, so this is also 127. 2 and 8 are vertical, so this is 53. And then again, let me get the eraser. Oh, here it is, eraser, let me erase this. It's not too clear. By some of the other relationships, this should be 53. Basically what happens is, if you come down here and work through them, angles, well, all the odd angles are 127 and all the even angles are 53 degrees. All right, let's go back over here. So we did that one, we did that one. Okay, what kind of a triangle is this? Two ways. We want to do it by sides and angles. So we've got two sides that are equal there. And we've got all the angles, so it's acute, and it has to be isosceles right here because it has two equal sides. And what kind of quadrilateral is this? This is a parallelogram. Oh, sorry. I was looking off and not paying attention. Let's try that again. Parallelogram. And now we want to do similar triangles. So let's go ahead and go over here. So we've got similar triangles and we want to find two sides here. We want to find the side X on this one and side Y. So the first thing I did was for side X, I set up my ratios. So X is to 2.8 as 6 is to 2.4. Cross multiply, 2.4x equals 6 times 2.8, which is 16.8. Divide both sides by 2.4 and you get a measure on this of 7. And then for y, same thing, I'm going to set up my similar triangle. So y is to 9 as 2.4 is to 6. Cross multiply, divide, and you'll come up with y equal to 3.6. And so the correct answer here is C, 37. Okay, 38. A triangle drawn on a map has side lengths of 9, 11, and 15, and the shortest of the corresponding real-life distances is 126 kilometers. Find the length of the longest of the real-life distances. So I've made a picture here. I want to emphasize these are not right triangles. It's just easier in Word to put a right triangle figure in. And so we want to set up the proportions again like we had before. So we want to find the length in real life over here. So x is to 15. The longest side of the one on the map, as the shortest side is to 9. And again, by cross multiplying and simplifying, you come up with 210, which is answer D. And then find the area of a triangle, 1/2 of the base times the height. Here's the base, here's the height. If you put that into the formula, you come up with 111 centimeters, and watch your units, centimeters squared. Okay, let's get back over here to number 40. This is a perimeter problem. Perimeter, you simply add the lengths of the sides. So 7 plus 8 is 15, and then again 15, so it's going to be 30. And then they want to know what the units are, and remember the units are the same units as the original measurement, so it's going to be yards. And I have a detailed solution for 41. This is a Pythagorean theorem, and we want to find the length of side A. So A squared plus 36 squared is 39 squared. Square your numbers. Subtract 1296 from both sides. We get A squared is 225, so side A must be 15, and it's inches. Oh, and then they wanted you to find the perimeter. So the perimeter is the distance around. So that's what I found here. I took the sum of the sides and I get 90 inches. And then finally they wanted me to find the area, which is 1/2 of the base times the height. And I came up with 270 inches squared. And then find the circumference. Remember circumference, 2 pi r. You're going to have these formulas available in the first question, remember. So 2 pi r, so the radius here is 9. So 18 pi. And they said use 2.14 for pi, and if I multiply that out by 3.14 by 18, I get answer D. And then in this one, they want me to find the perimeter of the quadrilateral. Oh, first the area and then the perimeter. So the area of this is the base times the height. Now, the problem with this is notice the units are different. So we have to have the same units. So in order to get from meters, and if you look in the answer choices, they want the answer in centimeters. So 5 meters is equivalent to 500 centimeters. So 500 times 19 gives me 9,500 centimeters squared. And then the perimeter is simply the distance around the outside. So 500 plus 27 plus 500 plus 27 gives me 1054. Find the surface area of a sphere with a radius of 12 inches using the formula. And there's the formula right there. So if you put your numbers into the formula, and if I use 3.14, I get 1808.64, and if I use my pi key, I get a little tiny bit higher. Either answer would be marked correct. And then finally, find the surface area of the figure. And remember, surface area, you have 2 of each side. So there's 2 of this side and this side, 2 of the long sides, and then 2 of the top and the bottom. And if you go ahead and put the values in given in the figure, you come up with a surface area of 32 square feet. And that should help you get ready for your proctored midterm.